The topic of presentation today of my lecture is the use of virtual reality for ergonomic analysis of physical load. So I mainly, for this presentation, I'm mainly focusing on the ergonomic side of my research. I'll talk a little bit more exactly what I do in my research, but I also have now a different line of research. Is still related to virtual reality, and but also focusing more on the educational side. I start with education, as you're gonna see, with ergonomics, and now I am not ergonomics is still my core area, let's say like this, but I also really enjoy to have this gamification platforms that we can use for students and to workers too. So I'm now also going towards that side for my research. But then we're gonna see exactly what I'm talking about in a few minutes. So as I already introduced me, I will go really fast for this slide. I'm assistant professor here in Chile. I am from Brazil. Obviously, I think you guys also can hear my accent. I am from Recife. I did my bachelor in the UFBA in architecture and urbanism. So, and then towards the end of my course, I decided, I realized actually that I didn't really like the more creative part of architecture. And I started to work with project coordination and all the management side of construction. And then that was basically my last year when I was doing my degree. And I went to the industry to work on that. So after that, I spent like a year working in Brazil after I graduated in the construction of a shopping mall. That at the time we used Beam to coordinate all the projects of the mall. And then I moved to Canada. I spent almost 10 years in Canada to do my master's and my PhD in construction engineering and management at the University of Alberta. So then there was when I got in contact with ergonomics, with virtual reality, with extended reality, and all of that. And now I'm Chile. It's gonna be soon it's gonna be 3 years. And here I continue the work that I was doing during my PhD. And now, as I mentioned, I'm also extending towards this more use of virtual reality, extended reality, also to education in general, also always related to construction. So my current research really focus on simulating and assessing different body motions using virtual reality. And I use some sensors that you're gonna see in the lecture to get this information regarding how the postures and how they move. With this information, I can assess if they are exposed to ergonomic risk or not. And I also focus on integrating these technologies to always improve workplace design ergonomics and also thinking about ensuring workers' health and safety. And okay, Regina, that's really cool, but why you do that? So why I decided to focus on ergonomics in construction, right? So when you talk about ergonomics, first of all, are you guys when I say ergonomics, I guess you are familiar, but do you know what I'm talking about? Because sometimes I go through and I start to talk about ergonomics and postures and workload, and then in the end somebody asks me, Prof, what are you talking about? So are you familiar with ergonomics when I say ergonomics, when I say that I'm improving workers' health and safety towards ergonomics? Do you know what I'm talking about? If not, if you don't know, if you want me to explain a little bit, I can do that. No problem. Yeah, I have one answer.
Yes, I understand.
Perfect. Cool. Uh, how can I go back now? True. Yeah. So just to make clear, so ergonomics is basically the relationship that we study the relationship between us, humans, and the place that we work. So for example, I always use this example because it's really true. Uh, when I was doing my bachelor in architecture, I towards the end of the semester, we had a lot of projects to finish, and I always have tendinitis. I would always end up going to the emergency, like the urgency, to get my hand treated because I would spend the whole night working my computer, and that would cause me some kind of injury. And then many years later, no, actually, during my bachelor, but I didn't know the reason. I changed my table, but I didn't know the reason. Uh, Years later, I understood that my table was horrible. Like I would definitely have an injury because my workplace was horrible. I know I saw your faces, so I think you kind of this a little bit similar age. But sometimes when I give this example to younger students, they don't get right away. But I think you guys remember that we used to have those computer tables that we have different compartments for different place for different things. So we have a table, the main table for the monitor, and we had that attachment below it to put the keyboard and the mouse. And that was a small space. So basically, I would be the whole night working on my project with my hand. Basically, I have my tablet. So that's the edge of the table, and my hand would be like this, right? Working on the mouse and changing views and seeing my 3D perspective, whatever. And that would definitely cause me an injury because I was putting too much pressure in a already really sensitive part of the body. So basically, what I'm trying to do for workers in the construction industry is to avoid these kind of injuries. Of course, they do most of the times they are not related to a desk, a traditional working desk, but they are always related to repetition and to other into awkward body postures, right? And basically, and why I do that? Because fatigue and work-related musculoskeletal disorders, which we call WMSDs, decrease really workers' physical and cognitive abilities, right? And also the motivation and the productivity. Because if you're working with pain, you cannot perform your job the best way. And that has also a cost embedded to it. So around $20 billion per year are expended just in the United States in the construction industry related to WMSDs. And that's just the directed cost. And as I described here in the right side, the directed costs are really just the tip of the iceberg because that's just related to workers' compensation payment and medical expenses. When we consider that we have all the indirected costs of training a new worker, all right, a replacement worker, the loss of productivity, the absenteeism because these workers are not coming to work, and also the social impact. We need always to consider that we are working in an industry that we do have a social impact. So imagine if you work the whole day, really have work, a lot of heavy workload, and you arrive home and you're gonna be arriving home, I don't know, to your kids, to your wife, and you're gonna feel tired. You're gonna have pain in your back, for example. So of course that also has generates uh, it impacts negatively on how you deal, how you have the relationships with your family. And all these costs can sum up to 5 times the directed cost. So it's really, when I say that, I really care about the workers' health, but we also have a huge impact on costs, like with money. So because in the end of the day, all really translates to money, unfortunately. So we have this great impact regarding the cost. And so far, I've had the pleasure to go to different. So I didn't mention that in the beginning, but I focus, at least so far, I've been focused on the study of ergonomics in industrialized construction. And since you guys already had the lecture of Professor Beda, I'm assuming that you know exactly what industrialized construction, offsite construction means. So I mainly focus my work on that. And I was really fortunate that I could go to different factories in different countries and always see almost the same problem. So in Canada, we have see here some photos of workers working in a plant, and they clearly have a really awkward body posture, right? So imagine doing this kind of position the entire day. And also in Brazil, I also went to different factories there, different plants, and we see the same. Walking a really awkward body posture, being like bending your back completely exposed there to injuries. And in Chile was the same. So when I went to also offsite construction plants here, I could also see is interesting because we will always end up seeing workers on top of elements on the tables because they cannot reach. So that they cannot reach, they cannot conclude the task if they are standing just around the piece of the house they are working on. So that means that although offsite construction, industrialized construction have a lot of benefits, and I'm not disputing that, we have a controlled environment. It's much easier to work in a plant than to be working a construction site, which we have different factors impacting on your environment. And especially when we're talking about Canada and also Chile, because Canada has a way harder winter. So the city that I was living, we would have average temperature during winter time of minus 25, and that would last for 5 months, around 5 months. And we could easily reach a week or two during the winter, minus 30, minus 35, minus 40. And so imagine walking outside in this kind of temperature is really hard. In Brazil, we have the opposite because we have really warmer and humid, depending on the city climate. So also we have the benefit of that when we work in a controlled environment. And in Chile, we have both actually, because summertime is here is really hot, and winter is not as cold as Canada, but also can reach some 5 degrees or so. Also. So we do continue having all the benefits of industrialized construction, but we see that clearly we can improve. There is some opportunities that to improve the workers' interaction with the environment. And that's mainly what I focus on my research. So I mentioned already a little bit of work. I mentioned basically the word work-related musculoskeletal disorder, which short of WMSDs. And what is that? So that's basically a group of painful disorders that affects your muscles, your tendons, or your nerves. And they are caused because of the overuse of the musculoskeletal system. So, and why? And they are really associated with repetitive work, as you can see here. Repetitive work of carrying boxes, carrying lumber, carrying tools from a place to the other the whole day. And also because of loads. So you can have a bending in your neck or on your truck, and also carrying heavy weight. And imagine doing that again the whole day. So that's some of the situations that we see in industrialized construction that can be a cause of work-related musculoskeletal disorder. And toward my presentation, I'm gonna mention two different tools that I use to measure these ergonomic risks. So I use HEBA and Ruler, which are not definitely not developed by me. They are tools that are there and the industry already use them to measure these ergonomic risks. So they are really good in our case, in industrialized construction, because they consider the posture of the worker relating to according to the angles that we have in different body segments, we have different scores. I don't know if you can see here. I think so. So depending on the angle of your neck, you have different scores of your trunk, of your legs, arms, like counting from your on top, and then also counting the below arm, so counting from your elbows, and also your hand. So we can basically consider the whole body. The main difference between REBA and ruler, the main difference is the REBA accounts for REBA stands for Rapid Entire Body Assessment, while RULA stands for Rapid Upper Limb Assessment. So RULA focuses on the upper body, so everything that happens above your waist, and REBA focus also on your legs. So basically, that's why I have this square here, which are the difference between the two of them. So this is for REBA, this is for RULA, and only REBA really considers the bending of the knee. RULA just asks you if you have both legs down or if you have one leg raised, but doesn't really account for the knees. And the wrist also has a little bit of difference, but nothing really significant. But the way, because they account for different things, so the way that the calculations happen after we have figured out all these angles are a little bit different. So that's why sometimes we use one or use another, or sometimes we use both to verify the risk of a task. And another thing that's really important is because they also consider the load that you carry. So if you carry a load, I have an increment of in the risk, and also the time. So it also considers if I'm repeating that task more than 3 times, for example, per minute, or if I am in a static position. So if I'm holding a weight for more than a minute, for example. So this is basically covers all the main factors that can cause injuries in the industrialized industry. So that's why I use both of these tools, REBA and RULA. And I will talk about them in this presentation. That's why I give an introduction, because when I show the case studies, I will mention the scores of RULA and REBA, and then now you know what I'm talking about. It comes it's calculated according to the angles of your body. In my research, I've been focusing mostly on operational training using VR. And this operational training now, as I mentioned, I'm expanding a little bit, not only to workers, but also to students. I have now a different branch that's not in this image right now. That needs some new projects that including I have a project now in collaboration with Professor Dayana, and also I have a different project uh, with Professor Toledo of USP. Focus on that. Focus more on the educational side of training. The project with Dayana is related to workers, but another one with USP is more related to students. So if students have a better learning curve or better learning experience when they are exposed to some part of the topics using virtual reality. So we're going to see this video larger in a few slides, so that's why I'm not focusing too much on it. But you're going to see what I'm doing there. I will explain because we have a full slide talking about this. The other side of my research is workstation prototyping. So basically, when we do ergonomic analysis and you figure out that workers are exposed to risks, that's great. We figured out that, but we need to do something with this information. So we have basically 3 options there, maybe 4, but I don't like the 4th one. The 4th one, let's say, is to ignore. You have the risk, but we decided to do nothing with that. Not great, but happens. Another option is to change the workstation, to propose a different design, to propose some different tool to improve your workstation. The other reason, that's the best one, because that gives us more freedom to implement more ergonomic friendly tools or workstations. The third one would be to try to change the way that the workers interact with this workstation. So I cannot change my workstation, but I can teach workers how to perform the task in a more ergonomically friendly way in the workstation they already have, which is the case. I'll also have a case study showing that in this presentation. And The fourth, the first one or the fourth one, now I've lost my line of thought, uh, would be the two of them. So if we can change the workstation and we can also train the workers to perform better in that changed workstation. So in this presentation, I will show two, two case studies. One, which we could change the entire workstation. And another one that we could, in a case that we cannot change, what can we do to improve the workers' health and safety in a workstation that we know that have some risks, but we cannot, for some reason, we cannot change it, the workstation itself. And that when this, when we have this scenario, I'm basically talking about ergonomics training. So I'm teaching them how to perform a task in a more ergonomic friendly way so they can prevent to get injured. So we will start with the case studies part of this lecture, showing a case where we can change the workstation. So here I'm doing ergonomic risk assessment and workstation prototypes through the integration of VR and sensors. I sent this paper to Professor Dayana, Dr. Dayana, before uh, the lecture. So I hope you guys have access to it. If you don't have, here is the title, so you can look for it. And if you don't have access, send me an email, then I will pleased to send to you. So the background for this case study was that we had, so basically when we have a workstation and we want to propose a new design for that workstation, and the company is really worried about ergonomic risks, which was the case of this company, it would be great to access the risks that they have now in the workstation that they are working on, and the risks that they will have in the workstation that we are proposing. To do that, usually we have physical prototypes like this one, really simple, made of wood. We did that in the shop floor at the university, and we could collect data. We could use the same sensor that I'm using with virtual reality, which here is a motion capture sensor called Xsense. You'll have a better view in the next slide how it works. And then this mockup system provides me with a video of all the motions that this worker is doing. And with that, I can extract all these angles, the angles that I need to calculate my ruler in rebase course. So I can have the average risk that the workers are facing towards the entire task, or I can even divide that based on subtasks. And based on this information, I can improve my design and propose a new design. And to verify if the design is more effective, I need to change my physical prototype. So especially this part here of implementing this change to the physical prototype can be really time consuming because depending on the changes, I need to basically do another physical prototype. So thinking about trying to solve this last part, I thought, why wouldn't it be great if we could do this assessment using virtual reality because we have the models. Usually when we design a workstation, the design team, they already work on some sort of 3D modeling. And if we could use the 3D modeling to create a virtual environment and test in this virtual environment, it will be easier to change, for example, the angle or the height of a table because it's everything in the computer and it's modeled in a way that it parameterize it, and then we can easily implement this change. So that's the motivation for this study. And in particular, this case study that I'm showing to you, we had this workstation, which was basically plain. So it was a table, and the workers needed to put all these frames and attach it to the frame of the window. At this point, this window doesn't have glass, so it's light, but they have sometimes huge dimensions. And they need to attach all the hardware in one side, then I need to rotate this window and attach the other side. And they basically attach all the hardware. So in another workstation, they can put the glass. And this case study was motivated by the company. They came to us asking to improve the ergonomics of this workstation because they have data that was a workstation that was a little bit problematic. And at the time I was doing my PhD, so we were part of a group with students for different backgrounds. So we have some students from mechanical engineering that proposed these two options of workstations, design IA and design B. And the main difference between them is the angle of the working surface area. This one is 20, this one is 60, and the height of the shelf where the hardware is stored. So this one we have a height, if I'm not wrong, 1.22 m, and this one we have it lower, a little bit lower. But we didn't know which design should we keep developing. And the company was really worried about ergonomics. So okay, let's use this to try you assessing ergonomic risks using virtual reality. So we did, since we wanted to compare to make sure that we could do that assessment with virtual reality, we did the physical prototype and the virtual prototype, and we collect data in both scenarios, and then we could compare them and make sure that if the assessment using virtual reality was also accurate, so in the future we could only use virtual reality. And here is a photo of the sensor, the Xsense mock-up sensors. So it's really light, as you can see, it's not invasive at all. We put a shirt, and then we have these sensors that are kind of squares, like this size. And we have the straps, and the workers can perform the movements really freely. They don't have any kind of limitation, and they are not easy to fall as well. So the objective of this study was, of this case study, was to propose a virtual reality-based simulation framework to assess ergonomic risk during the prototype phase of workstations development. So here was really important. Well, actually, always when we're working with virtual reality, especially when I'm towards ergonomics studies, to observe the task. So to go to the plant and check the main motions that the workers do in that workstation. And then once we verify that, we can also identify the key design parameters and, again, body motions that we need to make sure that the virtual reality is accounting for. So what I mean by that? So in this workstation, they would repeat the reach motion many times because they need to get the hardware and place it, position it in the right place. And after that, they need also to reach to pick up a drilling machine, a compacted drilling machine, and to assemble it, to attach it to the window frame. So I could observe that these three tasks repeated many times during the day, so they were really important. And based on that, I can verify which design features are related to this motion. So obviously here we see that the height of the shelf is really important. The height of the working surface area, right? The working surface area and the height and the angle. And also where in this shelf the hardware and the tools are positioned. Because if, let's say, if in the real environment, I have my shelf is here and my drilling machine is in this place, okay? And when I do that in my virtual reality, I put my drilling machine in this place. So the movement is going to be different because to reach here, I need to do this, the movement kind of putting my arms towards the center of my body. If I put it here, I could just extend my arm. And that changes the risk score because usually when you have a motion that makes you cross the body line, the middle body line, we have additional risk. So all these things we need to observe to make sure that the two environments are equivalent. So we can actually do the ergonomic risks in using virtual reality. So that is also always, we always do that. Always is a really strong word, but ideally you do that before even start to think about a VR model, because we need that's understanding the task. Then we start to build a VR model, and I use a reductionist approach, and that's why I try to identify the most important motions and design parameters, because for me, it's not really worth it to model the workstation in too many details, because that's going to cost me time, and time is money. If some details do not impact at all in my risk score. So I try to make the models kind of minimalistic, but making sure that the main motions are the elements related to the main motions are there. And then we can simulate the task using the virtual reality. And once we have the virtual reality done, we can invite workers or volunteers to do the simulation. And then with the body motion collected, I can calculate the ruling RIBA scores, so I can have my ergonomic risk assessment. And in this case, was also important to analyze the reach, so do a reachability analysis, because they had some complaints that sometimes they need to be really extended over the workstation to reach the top of it, for example. And the output of this study was basically I had the ergonomic analysis done during the workstation design development phase, and I could also identify the part of the body that were most physically demanded during the task. And why this is important? This is important because if I notice that I still have my arms are fine, legs are fine, neck is okay, but I still have a lot of tension in my back, and that could cause me an injury, I can verify which design parameter is related to that angle of the back, and then I can change that design parameter. So it helps us kind of give us a hint of which part of the workstation design needs improvement. And the validation process, in this case, I did a within subjective design experiment. So all the participants performed the task in both environments, in both the physical prototype and the virtual prototype. And I also used the doubling concept, which is we break down the movements of the body in smaller movements. So, for example, I could think about analyzing all these movements of raising my arm, reach, and placing as one movement, or I could break this movement in three. So reaching is the motion of extending my arm that's beside me or touching the workstation, and until it touches the object, and then that's one motion. And then the motion of picking this object and placing is another, or maybe even picking this object and bringing it to the right place, another motion. Placing it can be another motion, and attaching another motion, because I can, and this breaking down, if you go and search for doubling concept, is all there. They have different doublings that you can use, and we can basically break up our task following this. The structure is already there. And why I did that? Because most of the times, the time that a motion is performed in virtual reality and the real environment is not the same, the duration. And that gives me also precision to verify which sub part of the motion is being precise and which one is not. So I can also thinking about improvement. So I can improve my virtual reality to the motion to make it better, make a better simulation for motions that are not being accurate. Just a sec. Wait. I thought I was going to sneeze. So the criteria to verify if the virtual reality was being equivalent, or at least in a accuracy level that we would be satisfied, was to compare the Hula and Rebase scores, also to compare the joint angles, and I will mention a little bit more when we have a slide with the joint angles. I also applied the NASA TLX questionnaire to verify the satisfaction with the environment, and a perform a reachability analysis. For this presentation, I will focus on the first two because they are really, for me, the most important criteria at this point, because I will really focus on uh, the verification of the assessment of economic risks in two different environments. So, validation was basically what I'm trying to verify is if the motion in the physical prototype was equivalent to the virtual prototype. And here I'm showing videos of different persons, but we compare that the results for the same person and also as a group. So to make sure that we, because one person can, I don't know, have a really good result, but as a group, the average result is not satisfactory enough. And just a fun or curiosity fact, when I was getting ready to conduct the experiments, we had just finished assembling the physical prototypes. Pandemic had already started. So we could hear news every day about places shutting down and how bad the situation was in Europe and all of that. And basically, I did this experiment in the lab at the university, and I think the following week the university was closed. So nobody could go there and do the experiments, which would delay my research a lot because in Canada, I don't know how it was in Brazil, but in Canada, the university stayed closed for more than 6 months. And after it opened, we need to ask for permission, like the lab, we need to ask for permission so to be there and ensuring that we could follow some safety guidelines. So we could work in our workstation, but we could not invite people to do experiments. So that could have delayed my research at least, I would say, 8, 9 months. But luckily, we saw that things were going south with COVID. So my supervisor at the time said, Regina, if you have the workstations done, invite all the people that you can to come and collect the data, because then at least you have the data for the physical workstation. Because the good thing about a virtual reality is that it's a mobile system. So I could perform an experiment, I could collect the data anywhere. So I would not depend to go to the lab at the university. So because of that, making the story short, this experiment had a small sample size because it was really challenging to collect data during pandemic. But what I did to make sure that was something that I could publish and that I could validate, that I could generalize, I invited people in a way that they would represent some part of the population. So I invited human and men following some percentile of the North America population. So I got 50% percentiles, 75, 90, and 95. So with that, I could at least have some generalization of my results because they would represent a group of people. So that's something that is important when we're thinking about experiments in your research. And then, as I mentioned, the good thing about VR that it's a system that you can basically, if you have an area but not too big, depending on the experiment, you can still collect the data. So this is my living room when I was living in Canada. The university was still closed, but my professor allowed me to get all the VR. It was me and another two students working with VR at this time, but they were not using the equipment, and one of them had equipment at home. So he allowed me to get all the equipment and bring it to my house. So basically, I invited the same persons that had performed the task in the physical prototype to perform the test now in my living room. But it worked. At least I could collect the data and I follow all the safety guidelines. There was a lot of Lysol involved to clean everything. But then at least I could really collect the data and conclude my research without being waiting forever for the pandemic to be over. So the results of this study indicated, so this is Rula and Riba scores, right? And here I have by the colors the different designs and if they have been done, if these scores are the average for the physical prototype or the VR environment. So we can see, according to Rula, most of participants spend the time between medium and high risk range, which is something that it raises us a red flag that we still need to change to improve our design. According to Rula, to Riba, the same. So clearly here we have a higher score for the physical prototype of design B. For oh no, sorry, for the physical prototype of design B, they spend more time in the medium range, which is good. It's better to spend more time in the medium range than to the high range. And for that reason, we decided to go through to develop even more and to improve the design B option, which was the design option with the higher angle, the 60-degree angle. Okay, and also the height of the shelf was a little bit lower than the design A. Well, yeah, we had like a guess that would be the case, but now we could have some data to show the company, right? Because sometimes it's not only about having the theoretical perspective, but also to show them effectively we collect data, and that's the design that we should pursue because we quantitatively analyze it. And also an important finding of this research was that we could verify that we had, at least in this case, a more conservative ergonomic risk assessment. What does that mean? The participants spend more time in a higher risk range in the VR environment, which some people could say, oh, that's bad. For me, I face it as some kind of advantage, not advantage, but not as some kind of a benefit because we are then simulating to the worst case scenario. So if we have a simulation that provides us with a higher risk and then they go to the plant, we implement this workstation and they actually face a lower risk, that's great. It would be way worse if it was the opposite, right? If we had, okay, all good, and then we build it in the factory and then the risk that they face in reality is way higher. That would be a terrible scenario. So the fact that VR provides a more conservative economic risk assessment, so showing that they spend more time in a higher risk, for me, in my case, I consider it a good result because then we are developing to the worst case scenario. And as I mentioned, I divided the task in different doublings, which is breaking the motion down. And for the motion of reaching, which is a motion that they repeat many times, we could find a really high correlation. So, which was great because then we could verify that we could use VR for this kind of motion. Other important things, results of experimenting with virtual reality environments is to verify always trying to verify how to improve. So here, as you can see, especially for this person, which is a really tall person, he would be representing 95% of men in North America, according to the height. Basically, what we can see in these figures is that since this workstation for him was, the height was too low, we can see here there's his back is way more covered here than here, although the angle is not the same, but you can still see it also reflects here. So the VI environment, they have a lower risk score than the physical environment, right? So what happened? So why did this happen? Since the virtual environment, we don't have the weight of this frame. The weight is really light. So basically, when I do my studies with virtual reality regarding ergonomics, I choose tasks that the weight can be somehow ignored because they are really light. I'm not gonna say the weight of this frame, especially the size that we did experiments, and without the glass, without the hardware, I would say that's almost like a tablet or a computer or laptop. Less than a laptop, actually. It's light. I had this number in my mind, but I don't remember right now. But still, even though it's a lightweight, we would not be in real life holding the tablet while I'm drilling. I'm gonna get a staple. While I'm drilling, right? Because it's something that we would just, if I have a place to, a surface that I can put my tablet to help me, I would leave it there. I might have a hand just to hold it in place, but I would leave it touching the workstation because it's basically more convenient for me. Like I don't need to be holding one thing, and the drilling machine is, even though it's a compacted one, it still has some weight. So I'm not gonna be holding two things in my hands if I have a place to put it. And in the virtual reality, since I don't have this weight, he did that. He basically, what was the height of the table was not good for him, so he basically performed the task in the virtual environment as if he would be holding the frame and drilling with the other hand. As you can see in this image here, the frame is not touching the work surface area. And that's why he has a better posture because he's working a different height. So those kinds of things are good to happen in a way that you can verify that they cannot happen. So basically, after that, we changed the virtual environment so they cannot continue doing the task if some element should be touching the workstation because they would be in the real life. They cannot proceed and move on until they place the element in the workstation. So there's some kind of uh, uh, I forgot the name of the word. Some of the tricks that we can use to make sure that the virtual environment reflects the real environment. So basically, that's what I'm saying here, what's written here. And then also talking about the results, here we have the graph for the joint angles of the of the upper arm. So basically, as you can see here, the motion is really similar in both virtual and in real environment, which is good because that's important for us. And why I compare the joint angles in addition to the RIBA and ruler scores? Because I don't know if you still remember from the beginning of the class, RIBA and ruler, they provide me a sub-score for each body segment according to a range of angle. So can go, for example, the 0 to 20 for the neck, for example. But I want to make sure if, okay, I can still have, I don't know, a score of 1 if it goes from 0 to 20. But if in the virtual reality they are, I don't know, 19, and in the real environment they are in the 5 degree, the motion is not equivalent, even though the risk score would be equivalent, but that means that the motion is not equivalent, and at some points, if I'm too close to the threshold, this difference could impact my results. So that's why I also need to verify the joint angles and to see if they had a similar motion. For here, for example, I have a gap. So basically, in the virtual reality, they start the motion a little bit earlier. It was a longer motion. So if you see from here, basically here 0 to here, they had a longer motion. While in the physical environment was a shorter motion. The time that it lasts was shorter. So we still have a gap here, but since the motion, the trend of the motion was really similar, like you can see the maximum is really similar in both cases, and they go down and also really similar here, that allows me to conclude that the simulation was effective using virtual reality. And here we have the breakdown of reaching, moving. So basically here he's trying to get the tools, put it back to the workstation, and then positioning. So in summary, with this application together with a company, we could verify that it was possible to do a proactive evaluation of a workstation, right, during the design phase. And we had a strong correlation between the virtual reality and the physical reality, the physical environment, for some motions, right? So I got a really accurate prediction of reach and positioning. The motion of assembling, which is when you have the drilling in your hand, was not as accurate. And then there's a lot of aspects there. So basically, when you have a drilling, which I have one at home, but it's not close to me. When you have a drilling machine, there is a lot of motions in your wrist that are related to that, which the part of the body that's really tricky to get perfect angles, right? Because it's really a sensitive area. And it's also really difficult to simulate that in virtual reality because the position that you use to place it correctly and making sure that's actually working. Well, every person that already drilled something to something knows that if I do a task, probably the other person will be doing the different way. So it was really difficult to get a high accuracy on that motion. So that's something that we need to continue working on to improve the accuracy. But at least they reach a position, they had a really accuracy prediction, really a good accurate prediction. So with that, I finished the first case study, and I think we're still good on time. I will go to the second case study, and also related to user virtual reality and ergonomic analysis. But in this one, is that scenario. This one represents that scenario that if you cannot change the workstation, how can I make sure that still my workers are exposed to less economic risks? Because not all the times I have a company that's willing to invest in changing completely the workstation. Most of the times, unfortunately, most of the times we have a company that don't want to change anything. That's really bad to say, but that's most of the cases. So if you cannot change anything in the workstation, how we still have some improvement? So here the main goal was to verify the effectiveness of providing real-time ergonomic assessment and ergonomic training for workers to prevent the exposure to high range ergonomic risk. So we are basically trying to avoid the workers to reach to that level that if they reach many times in the day, they might have a serious injury. So to do that, I continue have some operational training using my virtual reality. When I mention operational training, what I'm basically talking about is showing the worker how they should perform the task, like which tool they should be using, which piece of the machine they should be focusing on, this kind of information. And now I also included ergonomics training, which is giving them some recommendations of how to perform the task according to the motion that they are performing in real time, in a way that they could minimize the exposure to a higher risk. So to do that, to do this real-time analysis, I'm continue using my mockup sensors. And now I am analyzing them in real time using my MATLAB script. And with that, I usually say, we need to observe the task again before everything. So when I observe the task, I already target some body segments that they will expose to a higher risk. So I can, in my MATLAB script, put a condition. So when this part of the body, for example, the trunk, is exposed to a higher risk, provide me a warning sound. And with this information, every time that the worker is exposed to that risk, I have a sound in the place that we're providing the training. And and then with this sound, we can trigger the ergonomic risks or ergonomics recommendations. And I was also collecting the heart rate and respiratory rate to verify the fatigue or physical workload during the task. And usually I like to do questionnaires to ask both the feedback, the physical perception of how demanded was the task, and also to get feedback of the simulation. So how can I improve? Kind of continuous improvement type of mentality. I always try to get information. How can I improve? And in this case study, I actually have some good ones. One person mentioned that, which makes totally sense, but I have never thought about that before, that the training was in a lab that was really quiet. So we had just the sounds of the AC system, but they are performing a task in the virtual reality, simulating a plant, a shop plant, which would be noisy. So the person mentioned maybe we should have some noise of background noise related to the factory that we are simulating the task running as a background. So they will not be feeling like in this really silent environment, which again makes totally sense. But I was so focusing on all the aspects that I have never thought about that. So that's why I try to get feedback from the person that are performing the task, because they might think about something that is common sense, but maybe it's kept my mind. It's kept my mind. So when I talk about operational training, that's what I mean. Here is basically we are in the development phase. So we're doing a try run in the lab. So that's why there's a student environment, and one of them is testing. So basically, we have a balloon that says the progression of your task. You can use your hands. You can use different tools. And we use colors to highlight where you should be working on. So which part of the machine you should be trying to disassemble, in this case, in this task, at that time. So you can put your tool back, use your both hands or one hand if you want to remove the piece, put it in the table, and then you're going to be repeating these kind of tasks until you can reach the drilling part of the machine, which is the one that needs some maintenance. So yeah, different colors to guide you through the task. And that's really basically it. So it's a task really with simple motions, but repetitive motions. So in this case study, in this experiment, I use a pre-test, post-test research experiment, research design, because I wanted to verify the impact of my intervention. My intervention means that I'm providing ergonomics training to workers while they are receiving also operational training. So in the beginning, and then I did that with 37 participants, and I had a control group to make sure that, so basically, in this study, I divided 2/3 of the participants did receive the implementation, so it received the ergonomics training, and 1/3 of these participants did not receive. So for the participants that were part of the control group, they received the same operational training 3 times. And for the participants that were part of the intervention group, they received the operational training, which is the one with the colors in the first time. And in the second time, they would hear this beep every time that they would be exposed to a higher risk. And this, I will put it back just to show again. And this ergonomic recommendation is related to the position that he is right now. So it's not a standard. So in order for the person to receive the ergonomic recommendation, they needed to be exposed to the risk. And according to the risk, a certain ergonomic recommendation would be given. So according to the part of the task that you are, and also to the body motion, that the body segment that the risk is related to. And the third time, the person would receive, again, just the operational training. And here I'm just making a zoom. So for the person that's applying, implementing the training, we could track in real time some graphs, important graphs. So for example, if for this task, I was focusing on checking the angle of the trunk, and the angle and risk of the trunk, and the dominant arm. So in the beginning, we would ask if the person was right-handed or left-handed, and we would observe that arm in more detail during the training section. And we could verify based on that. So since we have the 2 groups and participants receiving following this structure, so they have all they receive if the control group. If they're part of the control group, they receive the same operation training 3 times. Or if they part of the intervention group, they have here, the middle one is the intervention. So is when they receive the ergonomics training. And with that, I can compare for the same, I can compare between for the same participants and also as a group of participants. And I can see that the time that they spent, so the duration of the task, they spend less time of this duration in higher ergonomic risks after they receive the ergonomics training. So that means that I can, based on this information, I can say that the training is effective. They learn how to perform the task, and they reply that when they perform that task again. And again, we see a decrease here, but it's important to remember that in order to receive the ergonomics training, they need to be exposed to a risk. So some people, why we have a decrease? Maybe we should not. But because some people, since it's a really repetitive task, some people, when they were exposed one time to a motion of reaching, for example, and they received the ergonomics recommendation, they were exposed another time. They did that another time, and they received the same ergonomic recommendation. The third time, they were already doing it, even during the intervention phase, so they would not receive it again. So that's why we have some reduction here. And other people, no, they would just continue doing whatever they would do towards the whole intervention section. And well, then we have a reduction from 23% to 50% of the time in high risk rating, which is good because the lowest of if they spend less time in high risk range, decreases significantly the chance of them having a musculoskeletal injury, which is the main goal, is to make sure that they are not working with an injury caused by it. And we cannot see the same reduction. In fact, we have an increase when you see the control group. Maybe this increase is related because they are doing the same task again, they are tired, they think that's repetitive, and they don't know that how to perform it better. But you can see that there is no decrease at all in the time that they spend in high risk range for the control group. So based on that, we can attribute that the reduction is because of the training system that we are proposing. And here we have some examples of the same participant doing the task 3 times, and the breakdown of the time that she spent in each risk category. So she spent the beginning 16% of the time in the high risk range, then she decreased to 12 and then to 11. So that's an example of a participant that right away, when she starts to receive the ergonomic recommendation, start to implement it and already performing better during the training itself. Other cases, they perform better just in the end. It really depends on how quickly you are to incorporate that information to your body motion. And as I mentioned, I do love to do questions after experiments. And some of the questions that I'm really interested in are these ones that are highlighted here. I will just turn this way because I can see bigger. So question 3 says that I felt immersed in the virtual environment while experimenting with the VR application. And we had average score of 6 in the Likert scale, which means they agree. It's not strongly agree, but they agree. And here we have the breakdown. So most of them are in somewhat agree, or strongly agree. So we have no neutral or somewhat disagree. Question 8, I had a good understanding of the task being performed, which is also important because they need to understand what they're doing, because otherwise they're gonna leave the training and then go to the factory, and if they don't associate one thing to the other, one environment to the other, they would replicate basically what they were doing before. So it's really important that they understand what they are doing. And also here we have a really strong acceptance, so they agree with that. And also important that I felt that my body motions, movements during the VR experiment was similar to those in the real life. Also important because they need to correlate the motions that they are doing in the virtual reality with the real environment. So for this one, we still have a good percentage of acceptance, but we still have some people here that says neutral. They're not so sure if they're moving the same way. And also that's also related because the classes really make you feel immersed. So sometimes we are not really aware of the motions that you're doing. So in summary, and then with that, I finished the lecture and we can open for discussion. The integration of the virtual reality with the motion capture system and ergonomics training, we can really provide this learning by doing experience to reduce the ergonomic risks and also reduce the interference in the production line, because we can do that in the lab. And also, because we had a group and a larger group of participants, and we had a control group, we can have an empirical evaluation of the effectiveness of providing real-time ergonomic assessment during a training section. Also, again, focus on preventing ergonomic risks. And it was this case study that motivated me to also apply that to education, talking about university education, because that's learning by doing experience is something that's really engaging for students. So they feel that, especially when you have a gamified virtual reality, which was not the case for these 2 case studies that I'm showing you. I just showed you. The gamification of having scores, of having a real feedback, or having like a feeling of satisfaction during the process of learning, it's really interesting. So that's why now I also focus on that in my research. Well, that's all that I have lecture wise. We can definitely talk and discuss many different things now. Thank you very much. And if you have any questions, I'm here. And also, here is my email. So if you have any questions, if you have, I don't know, have any curiosity, anything, you can send me an email. Then I'll be my pleasure to reply.